Hello everyone and welcome back to my YouTube channel. I am Varshini and today we will be discussing from the subject Introduction to Python Programming. So today's topic will be polymorphism. Definition of polymorphism. Polymorphism is a fundamental concept in object-oriented programming that allows objects of different classes to be treated as an object of a common superclass. It enables flexibility and reusability of code. So types of polymorphism. Polymorphism can be achieved through method overloading, method overriding and interface implementation, providing different forms of flexibility in OOP languages. Application is that polymorphism simplifies code maintenance and enhances extensibility by enhancing the use of a unified interface for diverse classes. So basically when we initialize an object, we initialize it in the superclass and then all the base classes or inherited classes can also use the same object without having to reinitialize it. In this way we can reuse the same code that has been defined in the base class, and yeah, in that way we are reducing. It is time efficient, so we reduce time. It is flexible and is also enables reusability of code. It also avoids errors because once the code is written and debugged, the same code is reused again and again, so there is no problem of debugging the codes that are being used again, because once it is run and it's already correct. And then it is flexible, it enables flexibility in all the different OOP languages, and then it is used in overloading and overriding of methods, and then it is used for unified interface of a diverse class. Polymorphism and inheritance. Inheritance and method overloading, dynamic binding, and code reusability. Polymorphism is exemplified through inheritance, where a subclass can override methods of its superclass and provide specific implementations while being treated as the superclass type. Polymorphism allows dynamic method binding, where the method to be executed is determined during the runtime based on the actual object type, and it enhances runtime flexibility. Inheritance and polymorphism promote code reusability by allowing the use of common interfaces and behaviors across related classes. These are the different types of applications of inheritance that we just came through. It can be used to override methods of a superclass and provide specific implementations, and it also enables dynamic binding, where the method in which the program is to be executed, it is determined during the runtime and it enhances the runtime flexibility. And inheritance and polymorphism promote code reusability as we discussed earlier, and it allows to have a common interface between the behaviors related to the class. Now we'll discuss this SWOT of this concept, that is the strength, weakness, opportunity and threat from the polymorphism idea. Strength is that it enhances code flexibility and extensibility, reusability, contributing to efficient software development and maintenance. It using polymorphism, when we use polymorphism, it makes it easier to maintain and redevelop the software. So that is a very important application in the current day scenario, where everything is new and changing. It's evolving very frequently. And weakness is that complex polymorphic hierarchies may lead to challenges in the understanding and debugging of code, especially for large scale projects. When we have the large scale projects or big projects, in that what happens when polymorphism is used, it makes the flowchart very complex, and such complex scenarios can become difficult to handle. And if there are any errors or bugs in the program, it becomes a little tricky to find the bug and debug it. Now, opportunity is that use of polymorphism opens avenues for creating modular, scalable, and adaptable software systems aligning and evolving with business requirements. Making changes is easier, and it also evolves around with the evolving current day scenario, and it is also used for creating modular, scalable and adaptable softwares. Threat is that misuse or overuse of polymorphism may lead to code complexity, reduced readability and potential maintenance issues. If the polymorphism is reused or overused in a program, then what happens is that it can cause maintenance issues. That is, as we discussed as a weakness, it is very complex and difficult to debug. So in that way the readability is also reduced, so fixing bugs can become a little difficult, and that is one threat of polymorphism. Real world applications, it is used in UI development, the user interface development. Polymorphism is utilized in user interface design to handle diverse user interaction and behaviors through a unified interface. As we spoke, same object can be inherited in different class. That is what polymorphism means. And when it comes to user interface, such options provide space for unified interface, and it diverse user interactions. Basically, lot of interactions can be handled using the polymorphism webs. And software libraries, polymorphism enables the creation and reusable software components and libraries that can be integrated into various applications with different class implementations. And as we have discussed, polymorphism has its own library in the software. So what happens is that it can be integrated into various applications with different class implementation. Same library can be implemented and it can be given different methods or functions to be performed. The plugin architecture in polymorphism facilitates the development of plugin architectures, allowing the dynamic addition of new functionality without modular existence of code. Now, as we have plug and play devices that connect to our systems, and we can use it very simply and say, like we have the USB connectors and all these things. Similarly, we have plugin architectures in polymorphism too, which helps us to enhance the functionality of a code without having any modifications in the code, or we can just we can just modify the existing code. Now here we have interface implementation, that is also a very diverse application of polymorphism in OOPS. It helps in providing a unified way to interact with objects of different classes, which is referred to as interface polymorphism. Losing coupling is where it allows the class to interact based on shared behaviors and defined interfaces. Adaptability and extensibility is where enabling this the integration of new classes that conform existing interfaces. It is a very widely used application of object overloading. GUI development and event handling is another application. It involves event-driven polymorphism, the GUI development to handle diverse interactions and events through unified event handling interface. As we discussed earlier, there is one unified object and unified class, and the objects are used in different classes. Custom event handling, where polymorphic event handling allows creation of custom event handlers that can respond to various user actions while maintaining a consistent interface. We can have the same interface and handle different types of responses to the same actions, which is useful in the graphical user interface. And modular GUI components, here the development of modular GUI components that can be reused across different applications, that the same GUI is reused across different applications. That is a very important application, we can say, because the creation of different layouts for each application is avoided, which saves a lot of time and money. Last but not least, I would like to thank you all for watching my video. Thank you so much.